Hello everyone, you are learning physics from Uncle Irodov, and in this module we will be solving Irodov's 1.11. Now in this problem, there is a point from which two particles have been thrown. The two particles here are shown as A and B in the sketch. They are thrown in opposite directions with different horizontal speeds, but then their initial vertical speeds are equal, 0. And he's asking us to find out the distance between the two particles at the moment when their velocity vectors become mutually perpendicular. So the various steps when we try to solve this question will be these. We will try to find out the velocity vector of A, the velocity vector of B, find out the time when they are perpendicular. Now at that time, we should ideally find out the location where A is, which is A dash, and the location where B is, which is B dash, here in the sketch. And then we should find out the distance between them using the distance formula. But then the vertical displacement for both of these will be equal starting from t is equal to 0 up to a certain time t, because both had 0 initial velocity and both had the same vertically downwards acceleration and both moved for the same amount of time. So then the distance between A dash and B dash will be simply the difference between their x coordinates. So we don't even have to worry about y coordinates. So let us start from the very first step, finding out the velocities of these two particles at any time t. For the first particle, you will notice that we are using v is equal to u plus at, where u is 3I cap and acceleration is along the j axis, in fact the negative j axis, into t. So this is 3I minus gt j cap. Similarly, for the second particle, the velocity would be minus 4I minus gt j cap. Notice that the way in which these equations have been written, the first particle has been assumed to be thrown towards the positive x-axis. That would make B our first particle. So B dash is the particle that we are talking about when we say V1, and V2 is for A or A dash. Now whenever V1 and V2 are perpendicular, their dot product should be 0, which means minus of 12 plus g square into t square should be equal to 0. That gives you the value of time as this. So now the time is known. Now because the distance between these two particles will be simply along x-axis, we can find out the relative velocity of these two particles with respect to each other along x-axis and multiply that by the time for which they have moved. So VREL happens to be 7 because it will be minus 4 in this direction and 3 in that direction. So it is V relative is velocity of A minus velocity of B, so that is 7. So the distance between them is 7 into the time taken, whose general form is u1 plus u2 into square root of u1 u2 by g square, and after inserting the values, the distance is found to be approximately 2.5 meter. So this was a very short problem. I hope you have learned something from it, and I hope to see you in my later modules too. Bye-bye.